Hi, this is Dave with DavesTR4A. Welcome back to my channel. Well, as you can see, I've done a little more work on my overdrive control. A very good friend of mine has offered to do some graphics work for me for a label for the case. And it's pretty cool. We came up with the name RetroTech. I'm not going to incorporate into some kind of fancy business, some tool for that stuff. But anyway, just so we can have a website for the product for this and also for my voltage stabilizers. So anyway, that's the case. Eventually, the manufacturer of the case will be able to print this right onto the box and drill all the holes and everything. So that'll be a nice feature to not have to deal with. So anyway, that's the box. As you can, if you follow along, you can maybe you'll notice that this control board is slightly different. It has a bigger output relay. I have a great big flyback diode across the contacts of the relay, and I'll show you why I put that in here in a second. Still have all the other features of the original design. It's been very, very stable so far. Everything's working fine. I've just been slowly adding improvements as I play with the thing, but it's one of those things where if you're an engineer, you can't stop engineering. I've been accused of that. My good friend Jerry has told me that several times. So anyway, I got to stop and go ahead and get this thing rolling. So anyway, I'll talk a little bit about why I added this big diode here. Well, as I've said before, I designed my solid-state relay control to operate either an A-type, J-type, or a D-type Laycock de Normanville overdrive. Now, on the A-type, I basically am controlling the standard A-type relay, overdrive relay that's mounted on the inner fender of the TR4. And on the, on the TR6, the 68 version, I think it is, that has the A-type, similar situation. There's a relay on the inner fender that controls the overdrive, and basically what I'm doing is just energizing and de-energizing that relay. Now, I was lucky to get a couple of sample J-type overdrive solenoids and hook those up to the control and watch the operation of the solenoid as it turned on and turned off. Here's a picture of the D-type solenoid turning off that I took on my oscilloscope. So let me explain a little bit about what we're looking at here. So you can see that there's some lines on the oscilloscope there. I'm assuming you don't, this is for the people that are not familiar with oscilloscopes, okay? So there's a bold white vertical and horizontal line, okay? The horizontal line is ground, and you'll see there's lighter crossing lines there that are dividing the screen, and those are set for 5 volts per division, okay? So if you look to the left, if you count up, you'll have 2 1/3 divisions there. So that's 5, 10, like 13 volts, okay? So, and then you can see on the solid horizontal line that it eventually goes back up to ground. But what happens is when the magnetic field collapses on the solenoid, you get this reverse pulse, okay? And you can see that it's, 5, 10, 15, almost 20 volts negative going before it comes back up to ground, okay? So that's energy that this dissipated through the coil in the D-type solenoid, that's bad. We want to get rid of that because that's the reason why you see a lot of the overdrive switches on the J-types and the D-types basically failing because of this energy that's trying to be dissipated through the contacts of the coil, which basically makes them arc, okay? So how do you fix that? Well, the fix is to put a diode essentially across the coil of the solenoid. So let's see how we're going to do that. Because I'm going to throw up just a quick schematic. This is part of the schematic for the control. And I drew in the J-type solenoid schematic symbol there coming out of the the relay output on the control. And anyway, so D6 is the new diode, okay? And basically what a diode does is it only conducts one way, and it blocks voltage going the other way. So the way this is wired up now is that it'll allow the coil to go positive when you apply power to the solenoid to energize it. So when you turn it off, it shunts all that energy directly to ground. And you'll notice that I have what's called a single point ground there. And the whole object of that is we don't want to have all this noise going through all the logic circuit, because it's just going to totally screw things up and glitch things. So the standard practice is to create a single heavy trace or circuit line in the circuit board that goes from that diode back to the ground terminal on the terminal strip, separate from everything else. So if there's a pulse on the diode, it goes directly to the ground terminal and out to the ground on the car. So anyway, on to the results. So here's the end result of adding our new diode. You can see that when the solid state control turns off the solenoid, that new diode clamps the negative pulse pretty well. It only goes down about 2 volts, I guess, and then back up to ground, which is much, much better. So that'll make the whole system a lot more reliable, and it'll actually protect the solenoid a little bit too. So that's not seeing that pulse coming back through it. So anyway, that's it for the design. I'm waiting for my shift knob to come in, and then I'll do a video on the installation on my car. I've had a few people install them on their cars already, and they're pretty happy with them. So I'm anxious to have one on my car finally. So if anybody's interested in purchasing one, I'll have that information in the description on the video. And the shift knob is purchased directly from Jeremy Chin. I'll have his contact information also. And if you're interested in me sending you a copy of the installation manual to see if it's something that you can handle, I'd be glad to send you a PDF of that. And thanks again for watching, and stay tuned for the next video when I install this on my car. Thanks a lot, and I'll see you on the next video. I also want to include a quick reminder that I'm still rebuilding voltage stabilizers. I'm pushing 200 units so far, and over the last 2 years with no returns. So I'm very happy with that, and I have a lot of happy customers too. So feel free to contact me if you have a questionable voltage stabilizer and you'd like to have your gas gauge back. Thanks again. That's it for now. Please like and subscribe.